Let's talk about the antiderivative and indefinite integrals. So if big F prime is little f, then big F is the antiderivative of little f. For example, if we take the derivative of x cubed over 3, this will be equal to x squared. So x squared can be our little f of x, and x cubed over 3 could be our big F of x. We use the notation given here that the integral of f of x dx is big F of x, and we call this the indefinite integral. As with differentiation, there are rules for evaluating indefinite integrals. One rule is that the integral of the sum is the sum of the integrals. Another rule is that you pull out a constant when evaluating an integral. The next rule is the power rule, and it comes from the power rule that we use for differentiation, but it's in reverse. When we integrate 1 over x dx, we get the log of absolute value of x plus a constant. Similarly, when we integrate the exponential function, we get the exponential function back plus a constant. We can always add a constant to our antiderivative, and when we differentiate, that constant will disappear. So the constant is an arbitrary constant. The last two formulas are for integration of e to the kx, where k is a constant, and there we pull out the 1 over k power, and the integral of a to the x, where we get a to the x back, but we divide through by the log of a. Remember, we differentiated trig functions, and so now we can use what we learned about differentiation to write their indefinite integrals. So the integral of sine x dx is minus cos x plus the constant. The integral of cos x is sine x plus the constant. And when we differentiated tan, we got secant squared of x. And so the integral of secant squared of x is tan x plus a constant. And similarly for the other trig functions that you see here. So let's work through a couple of examples. The first one is given here, and we want to take the integral of 10x to the fourth minus 2 secant squared of x. And the first thing we do is use the rule that the integral of the sum is the sum of the integrals. And so we can write this as the integral 10x to the fourth dx minus the integral 2 secant squared of x dx. And then we can pull out the constants. So this will be 10 integral x to the fourth dx minus 2 integral secant squared of x dx. And then we can use the power rule on the first term. So that'll be x to the fifth over 5. And we will get a constant, but we'll leave the constant till the end here. And then we have minus 2. And when we integrate secant squared x dx, we get tan of x plus a constant. So that's the indefinite integral there. For the next problem, we have something that looks kind of interesting. We've got a sine of x on the top, and we also have a sine of x on the bottom, but it's sine squared of x on the bottom. So there is something we can remember here, though, and that is that sine squared x plus cos squared of x is equal to 1. If we rearrange this, we see that 1 minus sine squared of x is equal to cos squared of x. So we can rewrite this integral as being equal to integral sine x over cos squared of x dx. And then we can rewrite it one more time as 1 over cos x times sine x over cos x dx. Now, 1 over cos x is the secant function, so this is the integral of secant x, and then sine x over cos x is the tan function. And so we then can look back to our table and see that this is going to be secant of x plus a constant. Cool, eh?